Assalamu alaikum. Today I'm gonna talk about some components from slide 13 to till 19 till this slide. So and then I'll explain the components and explain what is written in the slides. So in this slide, Yuktide transformation Fe iron carbonate system. When it go down, as you see the black line, like this line, this one. When it's go down, the black line and change to ferrite and cementite. So ferrite has percentage weight of carbonate which is to 0.022, as you see below with the green or turquoise in color, and cementite has 0.77 weight percent of carbonate. So so you can see below it have 727 Celsius till it cooled and reach to 70 and 27 Celsius degrees C. So it transform to ferrite and cementite according what is written in the slide. Ferrite, as I said, contains 0.022 weight percent of carbon, and cementite 6.7 weight percent of carbonate. 0.77 weight percent of carbonate. Below ferrite and cementite, you draw how like you know all this information, like drawing a line here below the ferrite and drawing line here below the cementite. So in this brown color, you join a line from cementite to ferrite, or opposite from ferrite to cementite. It is, you can see with the brown, it is 727 degrees Celsius. Delta T it means the temperature that transferred is 727. So moving to the next slide, Yuktide transformation rate, dt. As I said, dt is the temperature growth per light from austenite. And what is first of all, what is perlite? Perlite is joining of ferrite and cementite together produce perlite. It began to consist granules of cementite, constant of granules of cementite. This make it to grow up and be taller. So producing perlite needs to join the ferrite and cementite together. And after the beginning of constant granules of cementite, this make it grow up and be taller. What I mean by being taller is perlite will be taller. So going out from ferrite and enter to cementite, the carbon concentration will be more, as you can see in the slide, in this figure or this circle. So here you can see the black points are the carbonate granules. So with the diffusion flow of carbonate needed, what mean it is carbonate. And reaction rate increases with dt. dt, as I said, it is delta temperature. So at larger larger temperature, it will be like the granules of carbonate will be cooked. So yes, we'll move to the next slide. Nucleation and growth. Nucleation, granules form and growth of it in three circles where we can see. I will explain them each by itself. The difference between three circles where we can see the difference between these three circles. The first one, this one, is from left side. First circle from the left side, where we can see when you are near Euclid temperature, the granules will be big. When I say it will be big, I mean the perlite granules. The nucleation rate is slow, but the growth is high. It grows fast, as I say, but then will be not much granules when you are near with high temperature. As you see, there is a two or few will be in a circle where you are near to Euclid temperature. In middle circle, T moderately below TE, nucleus rate mid growth. It means like in middle temperature and middle growth. So in this figure with medium temperature, what I mean, if you are below Euclid temperature, you see in the circle more granules, but they did not become big. So this where nucleation rate is medium, and also the growth rate is also medium. So with medium nucleation temperature, we will see many granules of perlite, but it will become like smaller than this one. So in the last circle, Euclid temperature is like under the nucleation rate will be so high, but growth rate is low and takes time to become big. It's all about nucleation growth. If you were near with high temperature, you will see as circle 1. And with medium temperature, you will see different case, as you see in middle circle. And the last one also, when you become with below the nucleation rate, this what you will see. So moving forward to the slide 16, isothermal transformation diagram. Isothermal, what it means? It mean the isothermal mean the constant temperature. Iron carbon system, where you see in this slide, the composition of carbon is 0.77 weight per percent of carbon. You see the transformation is at 675 degrees C. As you see here, the transformation is 675 degrees C. So the Euclid temperature the austenite transforms to perlite at 727 degrees C. At blue area or purple area, you can see the austenite is constant. When we go down with the temperature at 600 degrees C and fix the temperature, I mean like making the temperature constant, the austenite will be unstable. Why that this situation happens? Like, I will give you an example. When we have an ice cube, we put it in the fridge with a constant temperature, like -5, -6, -7. The ice cube will be same and stable and does not change. When we put this ice cube to the in kitchen or in like any other place where the temperature is not constant, the ice cube will begin to transform from stable to unstable, and that's why that's because of changing the temperature. So when you are at 727, the austenite is constant and they will be stable. It's all about the temperature going down and up. So let's talk more about this diagram and see what it have and what we can know from these lines and numbers. The green line means 0% perlite. What I mean, the perlite did not produce it till now. After while it reached the black line, like from the green light here, you can see it goes till black line. Sorry. After it reached to black line, it will become with 50% perlite, and take like 10 seconds to become 50% perlite, but without changing from what I mean in short words, like in the green line is 0% perlite. When you go and reach to black line, it will become 50% perlite, and the fully transformation is in the red line, where you can see 100% of transformation. So the temperature, and when you go till you reach the red line, this way you will have complete transformation, 100% transformation. So again, the red line is 100% transformation, and black line is 50%, and black line is 0% of transformation. After like 800 seconds, you will see the transformation from austenite to perlite. Moving to the slide 17, where we have an example of cooling history iron carbonate system. Octide composition CO equal 0.77 % of carbonate. It began at 727 and rapidly cooled to 625 and hold isometry. So the percentage of carbon in iron, the heated composition, you will have 0.77% of carbon. I will make the heat low, and you will make the heat low, and you will see black line. This black line you can see here. So as you can see the black line, and also you make it fixed temperature constant. This was austenite. This one is austenite, and it's changed to perlite. How it changed? By playing in the temperature. So where we can see first it's austenite, and then 50% of austenite and perlite, then it's perlite, fully perlite. So sorry. Beginning the transformation takes 3 seconds from to transform from, and it go till 7 seconds and then 10 seconds. So after 10 seconds it change from austenite to perlite. As you can see down these numbers. So after 10 seconds it changed from austenite to perlite, as I said. So the circle in the middle, it is what I said and mentioned. It's 50% of austenite and 50% perlite. This how transformation happens, like from austenite and perlite. Moving to the next slide, perlite morphology. Perlite, we put it under microscope to know of the type of it. Like there is not only one kind of perlite. There is, in this case, you see transformation just below TE and transformation below TE. In first case, it have larger diffusion and is faster. Perlite is coarser. And the second case, smaller, T diffusion is slower, but perlite is finer. What I mean, I will explain in seconds. So we have two cases. First is transformation just below Euclid temperature, and transformation will be below Euclid. So first is the cooling rate is high, and second case is low. In first, so when the temperature is high, it will lead to diffusing. What I mean that the carbon will kick faster from ferrite. With you can see white color here is ferrite, and black color is cementite. So when as I said, the temperature is high, it will lead to diffusing. What what I mean of that is carbon will kick faster from ferrite with white color, and the black color is the veins of cementite. The first circle we have thick ferrite, because all carbon will kick to sheets of carbon. You can see here they transform to carbon sheets. And as I said, like delta T is delta T is difference of heat is low in this case. So if you heated 727 and you from 1700 if you started to heating from at 727 and you go below at 700, like main heat is 727 and you go below, you heat like 700. The difference is 27, small difference, like yes, small difference. Metal is very heat, the kicking metals are very heat when the kicking of carbon will be fast, and this make